Alright, so just some review of the factoring that we did. I just wanted to make sure that we were all on the same page. I know it's been a little bit since we've talked about this. So difference of squares. So remember, in order for this to work, you have to have perfect squares and they have to be subtraction. So when we're looking at, we have a squared and b squared are perfect squares, and we have subtraction in between them. So given that, the square root of a squared would give me a, and then the square root of b would give, or square root of b squared would give me b and b. The only thing that you've got to make sure of is that you have a plus and a minus when you do it. So always make sure you check for GCF first. So when I look at this first problem, I have 7x to the fourth minus 343y to the fourth. And I should be able to see that I have, for 343, I can take 7 out of that. So if I GCF 7, that's going to leave me with x to the fourth minus 49y to the fourth. Now, when I'm looking at the problem, x to the fourth, that is a perfect square. Remember, anything with an even exponent is perfect. And if I have 49y to the fourth, that is also a perfect square. So I should be able to break that down even further. Now that GCF is still going to remain. I'm going to do two parentheses, one plus, one minus. So x to the fourth is, when we break that down, that is going to give me x squared. So I'm going to put x squared in the same spot x to the fourth would be. And then I'm also going to break down 49. So the square root of 49 is going to be 7 and 7. And y to the fourth, the square root of y to the fourth is going to be y squared. And there's my difference of squares. Alright, so just one more final example to make sure that we are all on the same page. There may not always be a GCF, but you should always check for one. So let's say I have 36x squared minus 1. And with 36x squared minus 1, I have 36 is a perfect squared, x squared is a perfect squared, and 1 is also a perfect squared. So I have that subtraction, so I should be able to do plus and a minus. So the square root of 36 is going to give me 6. And x squared, the square root of that is going to be x. And the square root of 1 is still going to be 1. Alright. And then we have factoring with trinomials. So if I'm factoring with trinomials where a is equal to 1, then we're just going to look at, I call it an X chart, but really we're just trying to find a set of numbers that would apply to the problem. So if I have x squared minus 7x minus 18, I'm looking for two numbers that when they multiply, so when they multiply, they're going to give me negative 18, but when I add them together, they're going to give me negative 7. So we're looking for my C value, multiply to get C, add to get B. So I have multiple options. I could do 1 and 18. Well, 1 and 18 can't get me 7. I have 2 and 9. So 2 and 9 could work. We just have to figure out how to manipulate that. So we need to multiply to get negative 18, but when we add them, we get negative 7. So in order to do that, that'd have to be negative 9. So we're going to take these two numbers that I just found, and I'm going to break them into two linear binomials. So this is going to be x plus 2, because 2 is positive, x minus 9. Alright, so again, you need to make sure you still check for a GCF if there is one. So let's say that I have 2x squared minus 18x plus 16. So when I'm looking at this, I definitely see that there's a GCF of 2. So if I take 2 out, that's going to leave me with x squared minus 9x plus 8. So now this has become a problem where a is equal to 1, because the GCF, when we took that out, that made my a value 1. So we're still going to do that x chart. So I need to multiply to give me positive 8, and I need to add to get negative 9. Well, 1 and 8 would have to work, but in order to make 1 and 8 work, we'd have to make them both negative. GCF is still part of the problem. So this is going to be x minus 1 and x minus 8.